So let's look at our first example. It says solve using the elimination method. Well, let's look at our system. We have x plus 3y equals 5 and negative x plus y equals 3. Technically, all we're doing right now is we're trying to find an x value and a y value that will work for both of these equations. Technically, some of you right now can probably figure out what x and y equals just by guessing, but there's going to be a limitation to that. Why? Because what happens when we have fractions? What's going to happen when we have decimals? Guessing and checking will not suffice. So we definitely need some algebraic method that will work for any type of numbers that we're given. So one of those methods is the elimination method. So we're going to go ahead and use that. The first step is to go ahead and stack the two equations right underneath one another. And the second step is to go ahead and combine these two equations. So how do we do that? All we're going to do is add the top and the bottom together. So in this case, you're going to add a positive x and a negative x. I hope that you realize that those will cancel out. Why? Because they are inverses of one another. And just a quick recap, inverses are just opposites. So a negative 2 and a positive 2 are inverses. A negative 3y and a positive 3y are inverses. A negative 100z and a positive 100z. Again, those are going to be inverses. Why? Because they are opposites. And something you should notice about inverses is whenever you add them together, they will equal 0. So in this case, they did equal 0 and we're counting it as they're being eliminated. We always want there to be only one variable because it's going to be a lot easier to solve. So it was great that the x terms were canceled. Now I'm going to go ahead and combine my 3y with the positive y, giving me 4y. I'm going to combine the 5 with the 3, giving me 8. So I have 4y equals 8. This is a great opportunity for you right now to use your common sense and ask yourself, 4 times what number gives you 8? The correct answer is 2. But if you don't want to use that, you can go ahead and use the algebraic method of trying to isolate your y by dividing both sides by 4, giving you 2. So it doesn't really matter. Both of them will give you the same answer. Technically, that concludes the elimination method. Right now, you're technically going to use the substitution method. You're going to substitute 2 in for all of your y's. So you get to choose whether you want to use the first equation or the second equation. I personally chose the first equation right here just because everything is positive and I feel that I'm less likely to make a mistake when I'm working with positive numbers. So I'm going to go ahead and plug in a 2 for my y, making sure I have parentheses. Is using parentheses important in this case? Yes. The answer will always be yes. Why? Because if I did not include these parentheses, I risk the chance of changing my equation completely. So for example, in this case, it would have been x plus 32 equals 5. And I know for sure 32 is not the same thing as 3 times 2. So, lesson is parentheses necessary? The correct answer is most definitely. Please make sure you include parentheses whenever you're substituting in a value. So I'm going to be left with x plus 6 equals 5. And again, when you have the chance, use your common sense. What number plus 6 equals 5? Some of you can tell me what the answer is, but if not, you can technically go ahead and try to solve it algebraically by subtracting 6 from both sides, and x equals negative 1. Then you're just going to write your solution as an x comma y. So the answer is negative 1 comma 2. What does this solution represent? Basically, it means the negative 1 represents all the x variables and 2 represents all the y variables. So please understand that you're technically not done. You're going to go ahead and check your work. And this is very important on your homework because you will not get credit unless you do check your work on a separate piece of paper. Please note that you're not going to show it on your work page. You're going to show it on a separate piece of binder paper. How do you check your work? Well, you're going to plug in a negative 1 for all the x variables. Make sure that when you do substitute them in, you do put parentheses. Then you're going to substitute a 2 in for all the y variables. So after you simplify the first equation, you should end up with 5. And then when you simplify the second equation, you should end up with 3. If it both checks out, you know for a fact that your solution is indeed -1, 2. But if something goes wrong and both one or both of those equations does not agree, then you know for a fact that you must have made a mistake somewhere in the process of solving for x and y. So that concludes our first example. Please just make sure you double check your work before you move on to the next problem.